Today's topic is preparation of amines. The first preparation is from reduction of the nitro compounds. Let's take some example. Nitrobenzene on reduction by hydrogen gas in presence of a catalyst like palladium in presence of ethanol is gets converted to aniline. Here the nitro group receives hydrogen and gets converted to the amino group, that is the NH2 group. Let's look at the second example. Here the starting material is same, that is nitrobenzene, and the reducing agent is somewhat different one, like tin in presence of hydrochloric acid. The HCl liberate out the protons which convert the nitro group into the corresponding amino group. Thus, nitrobenzene gets converted to aniline. The next is reduction of the NITRILES. The NITRILES are the compound containing the cyano group which has a triple bond between carbon and nitrogen. So when a compound like benzonitrile undergoes reduction in presence of hydrogen gas in presence of catalyst nickel, 2 pi bonds of the nitrile group are reduced and we get formation of benzylamine. Likewise, when acetonitrile is reduced with hydrogen gas in presence of nickel, 2 pi bonds are broken down and 2 hydrogens are get attached on this carbon of the nitrile group. So acetonitrile gets converted into ethanamine. Let's go for the next preparation of amine, that is from reduction of the amides. Let's take the first example of benzamide, which consists of a carbon-oxygen double bond. So when benzamide is reacted with the reducing agent like lithium aluminum hydride in presence of water, this carbonyl group gets reduced to the corresponding CH2 group, and hence benzamide gets converted to benzylamine. Let's look at the next example. If we start with acetamide, this carbonyl group, the CO group, gets converted to CH2 group, and thus acetamide gets converted to ethanamine in presence of lithium aluminum hydride and water. Let's go for the next synthesis, that is by alkylation of ammonia or the amines. For example, when the starting material is aniline and if it is treated with the alkyl halide like methyl chloride, this amino group attack on this carbon to bring about the nucleophilic substitution reaction. There is liberation of HCl, one of the hydrogen of this amino group, and this Cl will be liberated out as HCl, and thus we get formation of N-methyl aniline. This N-methyl aniline then reacted with the second molecule of methyl chloride. Once again, the nucleophilic substitution reaction takes place with the liberation of the HCl molecule, and the second methyl group, that is the methyl group of this methyl chloride, gets attached over this nitrogen to give an N-dimethyl aniline. This N-dimethyl aniline then is reacted with a molecule of methyl chloride. This nitrogen then attack on this carbon to bring about the reaction to give a product where we have a positive charge on the nitrogen. So this compound is called as NNN trimethyl anilinium chloride. Dear students, this nitrogen bears a lone pair of electron. So this carbon, being electrophilic in nature, gets attacked on by this nitrogen, and thus we get attachment of this methyl group over the nitrogen to convert it into the quaternary ammonium salt. The next reaction is the preparation of amines by Gabriel phthalimide synthesis. Here, the starting material is phthalimide that react with potassium hydroxide. There is release of the water molecule. The nitrogen acquire the negative charge by loss of proton, and the potassium ion forms an ionic bond with this negatively charged nitrogen to form potassium phthalimide. This potassium phthalimide is get reacted with methyl chloride. The potassium and chlorine react to form KCl, while this methyl group, being partially positive in nature, gets attached over this nitrogen to form N-methyl phthalimide. This N-methyl phthalimide then is reacted with aqueous NaOH. This aqueous NaOH means sodium hydroxide having solution with water. So water molecule attack on this carbonyl carbons of this imide and convert it into the phthalic acid. The phthalic acid on reaction with sodium hydroxide form sodium phthalate. With the formation of sodium phthalate, this methylamine molecule will be generated. So dear students, please keep this point in mind that this reaction is used for preparation of the primary aliphatic amines only. Only the aliphatic amines are synthesized or prepared by this reaction. Aromatic amines are not synthesized by Gabriel phthalimide reaction. The next and the last preparation is by HOFFMAN bromamide degradation reaction. This is very important preparation. Here the amide, for example this benzamide, gets converted into aniline. Here you can see that there is a loss of carbon. For example, benzamide consists of total 7 carbons, but aniline consists of only 6 carbon. So there is loss of 1 carbon from starting material to the product. That's why the reaction is called as degradation reaction. This reaction takes place in presence of bromine and sodium hydroxide, which react in situ to form sodium hypobromide, that is NaOPr. There is liberation of sodium carbonate, sodium bromide and water molecule. So starting with benzamide, we get formation of aniline. Likewise, if we start with acetamide, there is loss of 1 carbon, that is of this carbonyl carbon, and there is migration of the methyl group over this amino group to generate methenamine. Here you can see that once again there is loss of 1 carbon from the starting material. So that's why the reaction is HOFFMAN degradation reaction. So dear student, that's all about the preparation of amines. Thanks for watching this video. Please like, share and subscribe. Thank you.